Okay, the question 7 in the 2019 paper. Esters can be synthetic or natural. Synthetic polyester PET has many ester links. PET can break down by a free radical reaction. One of the steps involved in breaking down the PET is shown. Okay, so this is important that we have recognised this is free radical reaction, okay, and don't get drawn into the fact that it says ester links, because you're straight away you might have said, okay, well that'd be hydrolysis, but we're told it's free radical, and you've got here free radical and here a free radical, and what you should know is, oh, that's a terrible attempt at writing a word, let me try that again. Okay, initiation, propagation and termination are our three potential stages to do with anything to do with free radicals. Initiation means that you have no free radicals and you produce a radical. Propagation means that you have a radical on this side and you produce another radical. And termination means that you have a radical and you end up with no radical. This one has a radical and ends up with a radical, so this one is propagation. Part 2. Name the component of sunlight that can cause plastics such as PET to break down. UV. Okay. Name the type of substance that can be added to plastics to prevent them from breaking down. So free radicals, what we're looking at for prevention of damage by free radicals is to have antioxidants. Okay, that's it. Natural cyclic esters called lactones can be formed from hydroxycarboxylic acids. We have 5-hydroxypentanoic acid, and heated with dilute acid forms the cyclic ester. Okay, name product Y in this reaction. So we should know what you get if you're doing a condensation reaction, but let's actually just run it through to make it easier, or to show where we're going. Okay, so here we go. Here's our CO2. Sorry, not CO2, C double bond O. Here's a CH2, 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 CH2. Okay, so all of this is connected, and then we've got an O, so I'll take the O from there, which should make it quite clear what our extra is that we're left with. We are left with H2O, or water. Part 2, draw the structure for the cyclic compound formed when 4-hydroxypentanoic acid is heated with dilute acid. So what I'm trying to do is to do this, but with a slightly different chemical. Okay, and you're just following, the structures actually. So it's not, I don't think it's too bad. Okay, so we're going to put, I've not necessarily given myself the right space. So I'm going to keep my C double bond O, same place. Okay, but this time I'm just going to have 1, 2, oh, put my hydrogens on this side. 3, and I'm going to take my CH3 off to the side here because I need to bring my O back to this one. Okay, that's it. Name the hydroxycarboxylic acid shown below. Right, again, sorry, I can get this on the right place. There we go. So they've kind of given you above how this one was named, 4-hydroxy. So that's going 1, 2, 3, 4. And pentanoic acid, obviously, because that's a 5. So this one is 4 long, so that is butanoic acid. And 1, 2, 3. So 3-hydroxy butanoic acid. And that's the question.